Okay, so good morning, guys. We are doing this energy chapter. Still, a few more hours left. Okay, so this is seventh part. We are discussing some miscellaneous energy topics, right? And we started with fuel cell. Okay, wherein I have told you about hydrogen. Yes, and then I have told you about the mechanism of microbial fuel cell. Okay, so today we're gonna see one more topic, which is biomass gasification. Second one, biomass gasification. Biomass gasification. Okay. See, before also we have seen biogas. Okay. What's the difference? I'll tell you everything here. Okay. And then I'll take you through generations of biofuel. There you will get some more clarity. Okay. So when I say biomass, here we'll use in the gasification, we'll use biomass baggage. Baggage means in the production of sugar. Okay. Like say, we are going for sugar cane juice. Okay. Once we get the sugar cane juice, the leftover is nothing but baggage. Okay. And then rice husk, which means let's say this is rice grain, and on top of that you will be having a layer, right? That is nothing but rice husk. Okay. And then coconut coir. Okay, the material. Okay, again stubble. Okay, so in the production of wheat, once you remove this wheat, the leftover is nothing but stubble. In the Punjab, what they'll do is, instead of taking it out, what they'll do, they'll burn it out. That's the reason you'll see smog in the Delhi. Yes, here you will be having Punjab and here you will have Delhi. Okay, here what they'll do, they'll burn the stubble here. Okay, and the pollution will reach to Delhi. In Delhi we have fog in winter season. This fog will mix with smoke and it will create smog, and it is really dangerous for human health. Okay, so here what's happening here is, why this biomass gasification concept came is, see, these things if will burn open, it will create massive environmental pollution. Massive environmental pollution. So to get rid of this massive environmental pollution, we came up with a concept called biomass gasification. So write down in the same way. See, here stubble means in the field you'll grow wheat, right? Yes. Wheat you'll form in the form of seeds. You'll find in the form of seeds. Once you remove this wheat, okay, you'll separate this wheat, you'll be left with this stubble, grass. Okay. This grass is nothing but stubble. Okay. So generally in Punjab you'll find this. Okay. More. And there people what they'll do is, I mean, instead of taking it out from the fields, okay, in the night they'll come up with a kerosene bottle. In the night they'll spray that kerosene on this stubble and they'll burn it out, everything. Okay. So immediately, I mean, see, if they have to take it out, they have to hire laborers. Okay. They have to pay 1,000 rupees per day. Instead, they'll simply buy some 100 rupees kerosene and they'll pour it on the stubble and they'll burn it out. Okay. So this is the process. So my point here is, whenever we are doing this open burning, it is creating massive environmental pollution. Therefore, write down biogasification. Biogasification is a sustainable method. Is a sustainable method. Sustainable method for the utilization of biomass. For the utilization of biomass. For the utilization of biomass. Okay, so nothing but biomass gasification. This is a method wherein we'll use this biomass in such a way that it will be helpful for the sustainable development. Okay, which means no pollution. Okay, so here what happens here is simple. The basic concept I'll tell you. See, biomass will take. Okay, see, if we'll burn out this biomass in the open field, then only it will create pollution. So what here will do is, will take in a closed container in the absence of oxygen, and then we'll burn at high temperature, and the process is called as pyrolysis. Pyrolysis, see, in my physics classes I have told you about pyrometer. Yes, thermometer to measure the temperature, and the pyrometer to measure the temperature at higher temperatures. Yes, here whenever you are burning something at higher temperature, then the process is called as pyrolysis. Then we'll get a good result. Okay, so this is the concept behind, and I'll draw the diagram. First write down this concept. So here what we are doing is, biomass we are taking in a closed container, which means in the absence of oxygen. Then we'll burn this biomass at higher temperatures, 700 degrees, 600 degrees. Okay, and the process is called as pyrolysis. Then, understood? So pyrolysis means burning of anything at higher temperatures, not in the absence of oxygen. Generally, at higher temperatures is nothing but pyrolysis. And there, keep a note point and write down. The instrument used to measure higher temperatures is pyrometer. The instrument used to measure higher temperatures is pyrometer. Like to measure the temperature of sun. All these things you'll measure with the help of pyrometer. Okay. For your temperature, barometer or thermometer will be used. Sorry, barometer, thermometer will be used. Okay. Okay, fine. See here. Now, see, draw the picture along with me. See, here we have an inlet. Here we have a inlet. In the inlet, what we will be doing is like we'll place a grinder. What is this? Grinder. Why grinder? See, generally biomass will be in large in size. Okay. So with the help of grinder, we'll cut into small pieces. Okay. Example, coir. Okay, we'll cut into small pieces and then we'll allow them to enter into the closed container. Okay. So generally, I mean, see here what we are doing, we are converting the complex material into simple material. So before that, the complex material we are grinding, we are cutting into pieces. Then we are allowing them to enter into the closed container. Okay. So in the inlet, what we are placing? Grinder. Okay. So this grinder is connected to a closed container. Closed container. Okay. So this closed container, we have biomass. Okay. And there is no oxygen in the container. Okay. Now what we'll do is we'll do the process of pyrolysis. Pyrolysis means burning the biomass at higher temperature. So to burn this at higher temperature, what we'll be doing is like we'll take LPG, propane and butane. Okay. And then we'll burn. Will burn LPG. Will burn this to 400 to 500 degrees Celsius. Any doubts till now? Any doubts till now? No. See, generally the thing here is, see, without oxygen, nothing will burn. Without oxygen, nothing will burn. So here to burn, here we need oxygen. Okay. So the material inside will take them to 400 500 degrees Celsius. Automatically it will burn, just like keeping a pan, and on the pan you are placing an omelette. Okay. Take this as an omelette. Even I mean in the absence of oxygen also omelette will fry, right? Only because of the temperature, the temperature which you are giving to the pan. To give temperature to the pan you need oxygen, but to burn the omelette on the pan you don't need oxygen. The same formula. Understood? You may ask me this question: without oxygen, how come this biomass is burning? Here it will burn because with the temperature it is burning. And the temperature is provided with the help of oxygen only and LPG. Okay, draw till this. And this process is called as pyrolysis. Actually, it need a big space, okay? Leave some space. Or else let me complete the diagram first. Wait. See, then what happens is whenever we'll burn this biomass, it will break into small particles. It will break into small particles, will find some small particles and some big particles. Will find some small particles and big particles. Some small particles and big particles. This will transfer to another container. This will transfer to another container. This will transfer to another container, where we'll have a machine like this, and this machine will rotate like this, and this machine will rotate like this, and this process is called as ultra centrifugation. Ultra centrifugation. What this process will do is, see, this process will separate this large particles from the small particles. Okay, so all the large particles will be separated and they will be collected in a container. They will be collected in a container, and these are solid particles. These are solid particles, and this is called as biochar. Biochar. This is solid in nature. This is solid in nature. Now we left with, we are left with small particles. We are left with small particles. Now the small particles will enter into one more container, one more container, one more container, one more container. From in this container, we'll spray some water. What will spray? Water. So these small particles, okay, and there are some gaseous nature particles also. Whenever we are spraying the water, what happens here is whatever the gases are there, okay, so these small particles, what they'll be converting into liquid states. Liquid states. So here what happens is, below we'll find water. Below we'll find water. Above that we'll find the oil. Above we'll find oil, and the remaining gases will come out from this outlet. Okay, and the gases are methane plus carbon monoxide plus H2. Carbon monoxide plus H2. Okay, this oil will separate, this oil will separate, and this oil will call it as bio oil. This oil will call it as bio oil. See, let me repeat the process again. We have taken biomass. Okay, that biomass is entering into a inlet pipe. In the inside the inlet pipe, we have a grinder. What this grinder will do, this will cut down this biomass into small pieces. Now this biomass will enter into a closed container, a closed container. Now this closed container is burning with an LPG cylinder. Okay, and the burning temperature is high, 400 to 500 degrees Celsius. That's the reason this process is called as pyrolysis. Now this will burn, and once this will burn, this will break into some small pieces and some large pieces. Okay, so this will break down into some small and large pieces. Okay, now we'll separate these large pieces. Okay, these large pieces through process called ultra centrifugation. Okay, ultra centrifugation is nothing but, see, you have taken curd and you will use an instrument called kavam. Okay, I don't know what you will call it as in English. Okay, and you'll rotate it like this, spin it like this, and this process is nothing but ultra centrifugation. Okay, now here we'll do that process, and this process, what it will do is, it separate all the large particles. It will separate all the large particles. All the large particles will be collected in a tray, and this tray, the large particles, is called as biochar. Biochar. Okay, and we are left with some small particles. Now the small particles, on top of the small particles, will spray some water. Okay, these are very high in temperature. Once you'll spray some water, they'll come to normal temperature. Once they come to normal temperature, they'll convert into oils. Okay, see here you are spraying water and the particles are converting into oil. Now see, oil density is less and water density is more. So oil never will, it will mix with water. So water will come down, oil will be above. So oil will be above and water will come down. First we'll remove this water outside and then we'll collect the oil. This oil is called as bio oil. And then some gases will come out. Gases, methane plus carbon monoxide plus hydrogen. Okay, and these two gases are called as syn gases. Syn gases, nothing but synthetic gases. Okay, they are not natural, through the process it came. So these gases are syn gases, and this is our end product. End product, and these two are byproducts. These two are byproducts. Now here you'll get methane in large amount. You'll get methane in large amount. So what you will do is you'll connect this methane to this tank, to this closed container, and you'll burn this closed container now with the help of methane. So initially you are using LPG. Once the process started, you'll get methane. Once you'll get methane you'll get here in large content. So out of this large content methane, let's say you are getting 100% methane. Out of 100%, you will take 30% and you'll utilize this 30% for the heating of this biomass. So initially only you will require LPG. Later, with the help of methane itself, you will convert this you'll biomass into small and large particles. Understood? And remaining 70% methane, what we'll be doing is, remaining 70% methane, what we'll be doing is, we'll get the heat with the help of this methane, which means we'll boil some water, we'll get vapor, and this vapor will rotate the turbine, and the turbine will give you mechanical energy. Mechanical energy will convert into electrical energy with the help of dynamo. So with the remaining 70% methane, what you'll do, you'll convert that methane into electricity. Okay, and this hydrogen gas, this is obviously it is a fuel. So you'll use this as a fuel. Okay, and I'll tell you the advantages of biochar. Okay, draw this picture. Any doubts here? See, again, this is harmful for environment, but if you are doing this process outside, then it is harmful. But all this process is happening in a closed container. Okay, so here in the outlet you'll place an instrument or a thing called scrubber. Scrubber, what this scrubber will do is it will absorb carbon monoxide. Why it will absorb? See, carbon monoxide, it is highly dangerous. Okay, why? It will react with hemoglobin. It will react with hemoglobin. Okay, whenever it will react with hemoglobin, it don't allow oxygen to react with hemoglobin. Once oxygen is not reacting with hemoglobin, then you won't be allowed to able to take the air. Okay, inhale or exhaust, then immediately you'll die. Understood? So here this carbon monoxide, always it will react with hemoglobin. Once it will react with hemoglobin, it won't allow oxygen to react with hemoglobin. If this is the process, then you will be suffocating and then you'll die. That's the reason what we are doing here is we are placing a scrubber here, and this scrubber is absorbing the carbon monoxide. Methane, we are 30% we are using for the pyrolysis purpose, and remaining 70% we are using to get electricity. Hydrogen gas, anyways, it is a fuel. Okay, so in further processes we may use this hydrogen gas, and about this biochar I'll tell you. Okay. See here we have seen pyrolysis, and then in the next tank we have seen ultra centrifugation. Okay, and then we have sprayed some water in the next tank. Okay, simple process. None. So what I have told you, biomass gasification is more sustainable method of using biomass. Biomass gasification is more sustainable method of using biomass. See, before also we have used the same concept, biomass. We have taken, yes, and then in the absence of oxygen, we have inserted some bacteria. Now this bacteria, they have break down this biomass into some simple components, and the end result we have got some methane plus carbon dioxide. Okay, so I have told you, I mean, see, this you'll get in 60% and this you'll get 40%. So to use it as a fuel in the vehicles, you need minimum 80%. I have told you this process. Yes. So here, see, at least here you are getting carbon dioxide and this is mixing in the atmosphere. Carbon dioxide and this is mixing in the atmosphere. But here in the biogasification, on one side, we are getting biochar. Okay. See, this has, I mean, really good uses. Okay. I'll tell you about these things. Okay. And then bio oil. See, bio oil means the oil which is useful for friendly for the environment. So I have told you in the environment and science and tech, wherever you are finding a word called bio, then it is environmental friendly. If I'll tell you about diesel, then it is not environmental friendly. If I'll tell you about biodiesel, then it is environmental friendly. Okay, so this is also environmental friendly. And then you are getting, what you are getting? Methane. Okay, so this methane, on one side you are using the same for burning the tank, and on the other side you are producing electricity. Electricity. On the other side you are getting hydrogen fuel, no pollution at all, and this has high calorific value. This has high calorific value. And we are left with carbon monoxide, and this is observed by scrubber. This is observed by scrubber. So nowhere you are finding pollution. So we started with this process wherein I have told you, if we'll do the open burning, then obviously it will create massive environmental pollution. So what we are doing is, this biomass, instead of open burning, we are taking it in a closed container, and then we are burning. And then we are burning. And I have told you this process will give you the good result. And the result is this. The result is this. Understood? Yes? That's the reason initially I have told you biogasification is more sustainable method of using biomass. Okay? Now, we'll see some more things. Write on this. 30% CH4 will be used in the process of pyrolysis. Pyrolysis. 70% methane, it will produce heat, and this heat will be converted into electricity. And then write down there, carbon monoxide is dangerous, or else I'll dictate this. First write down these two things. Then now write down carbon monoxide, carbon monoxide, CO, carbon monoxide, carbon monoxide. If we have two O's, then we'll call this as carbon dioxide. Here we have only one O, so we'll call it as carbon monoxide. So carbon monoxide is dangerous for human life. Human life. Because 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 it will react with hemoglobin. It will react with hemoglobin. It will react with hemoglobin. Later it won't allow. Later it won't allow. Later it won't allow hemoglobin to react with oxygen. Hemoglobin to react with oxygen. Later it won't allow hemoglobin to react with oxygen. Thereby people will die with suffocation. Thereby people will die with suffocation. Thereby people will die with suffocation. So here it will be absorbed by scrubber. 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 Understood? So any doubts in this process? So quite technical, but still I have made it easy for you. Okay, simple. Grinder will divide the complex particles into small particles and then will heat them using a process called pyrolysis. During pyrolysis, this biomass will be split into small simple particles, and this simple particles may be of larger size or may be of smaller size. Larger size will separate and will call them as biochar. Okay, and smaller particles, they are at higher temperatures, will spray water on them, and some will convert into gases and some will convert into oil, and the oil will call it as bio oil, and the gases will get CH4, methane, carbon monoxide, hydrogen. Okay, carbon monoxide plus hydrogen together will call them as syn gases, which means synthetic gases. Okay, through natural process we are not getting these gases, through a process we are getting, that's the reason we'll call them as syn gases, synthetic gases. Okay, and this carbon monoxide will be absorbed by scrubber. Okay, and again we'll use the CH4 for the heating of tank container. Okay, now we'll see the advantages of this biochar. Okay, so keep a heading as coal ash, fly ash, biochar. Coal ash, fly ash, and biochar. So first we'll start with coal ash. Coal ash, nothing else we have to see here. Coal ash, I have already told you. See, in the coal chapter, I have told you there are many types of coal. Yes, what are they? Anthracite, bituminous, lignite, and peat. So in the anthracite, we have more than 80% or close to 80% of carbon. So remaining 20% will be your coal ash. Remaining 20% will be your coal ash. So write down. Residual part, residual part or substances after the burning of coal. Residual part or substances. Residual part or substances after the burning of coal. Okay, it may have, next point, it may have presence of, it may have presence of heavy metals, heavy metals. It may have presence of heavy metals. Okay, what are those metals? Write down: cadmium, arsenic, lead, mercury, etc. Okay, so in the examination they'll ask you which of the following metals will be there in the coal ash. Okay, cadmium, Cd, arsenic, Ar, lead, Pb, mercury. Okay, so some heavy metals will be there in the coal ash. What are those metals? Cadmium, arsenic, lead, mercury. Okay, so if in case, okay, if there is a pollution in your area, if you are taking this air which is containing lead or mercury or arsenic or cadmium, then obviously this is dangerous for your health. Okay, it will create some respiratory problems. Okay, so this is all about coal ash, and the question will come on this only: presence of heavy metals. Presence of heavy metals, so cadmium, arsenic, lead and mercury. Okay, next, fly ash. Fly ash, see, this is also a residual part, a residual substance in the burning of coal process, but the thing here is this is light in weight. Right now this is a light in weight, light in weight. So what happens when it is light in weight? It won't settle down on the earth's surface, instead it will suspend in the atmosphere. It will suspend in the atmosphere. So this you'll read in your newspapers as particulate matter 1.0, particulate matter 2.5, particulate matter 10. Okay. See, in your, in like, I mean, if you're going to cities like Vishakhapatnam, I don't know. In Bhubaneswar, I have seen, wherein you'll be seeing a big TVs in the traffic areas, okay, in the signals, and there you'll find PM 2.5, PM 10 percentage they'll give you. Okay, so that PM 2.5 is nothing but this only, fly ash. Okay, so this in Delhi you'll find more. In Delhi you'll find more, because see, residuary part of this. See, I have already told you, in the biomass, in the stubble burning, there also you'll get some residual substances. This residual substances, if they are light in weight, then they'll obviously suspend in the atmosphere. So that's the reason from here Punjab to, it will travel to Delhi, and in Delhi they'll suspend in the air. That's the reason in Delhi you'll find more particulate matters 2.5 and 10. Okay, understood? Fly ash. So fly ash is nothing but this is also ash only, but the thing here is this is light in weight, and this will suspend in the atmosphere. And this generally you'll call it as PM 2.5, PM 1.0. 1.0 before we, this is not an important topic for UPSC, but now this is quite popular in the newspapers, so this is also an important topic for UPSC. Okay, so this is the thing. Okay, now we'll see some disadvantages and advantages of fly ash that were asked in UPSC. So write down disadvantages. Disadvantages. Okay, first one, aerosol particles. Aerosol particles. Aerosol particles, which means they are suspended in the atmosphere. They are suspended in the atmosphere. Okay, now this contains, first listen, then you can write. This contains black carbon. Okay, what is this black carbon? I'll tell you. Black carbon, brown carbon, green carbon, everything I'll tell you. Okay, for now, this contains something called black carbon. What this black carbon will do is, it will create greenhouse effect. Okay, how this black carbon, it will capture, it will trap the infrared rays. Okay, in my physics classes, I have already told you, if you are feeling sweat, if you are feeling hot, then the rays which are affecting you is infrared rays, not UV rays. Okay, so global warming is because of infrared rays. Those infrared rays will be captured or trapped by this black carbon. So these are aerosol particles. They will be suspending in the air. Okay, now let's say, see, this is our earth. on top of that we have atmosphere. In the atmosphere, if we have black carbon, okay, so in the atmosphere if we'll have black carbon, now what happens is sun rays will enter, sun rays will enter, and they'll reflect and they'll go out, they'll reflect. But the thing here is, if there is black carbon in the atmosphere, okay, so along with the sun rays, infrared rays will also travel, okay, but this black carbon, it will trap the infrared rays, which means they'll again reflect to the earth's surface. So in the atmosphere, for sure you will be finding infrared rays, and this will create global warming. Understood? So in geography also you'll learn this. Okay, I mean, see, in Norwegian regions, okay, there they won't get much temperature, much heat. So for agriculture process, what they used to do is they used to construct a glass house. Glass is nothing but carbon only. Glass is nothing but carbon only. I mean, you tell me something. See, if you are parking your car, okay, in the sunlight, what happens? Whenever you'll open the door, you'll feel warm. Why? You know the reason? Because this carbon will capture infrared rays. Whenever sunlight is entering into your vehicle, okay, this sunlight will reflect again, but while reflecting, the infrared rays will hit the mirror, and this mirror, this glass, it will capture the infrared rays. So infrared rays will be there in the car only. That's the reason whenever you will open the door of your car, infrared rays will come out and you'll feel warm. Okay, same effect they'll use for agriculture. Okay, they'll construct a glass house. They'll construct a glass house. Now what happens here is, here sunlight will come, and this sunlight is not that intensity. I have told you. Okay, in the pole region you'll get sunlight, but intensity is quite low. Okay, now this sunlight will come inside the glass house. Okay, but this sunlight, once entering into the glass house, it won't leave the glass house. It will be trapped in the glass house. Okay, with less intensity, they'll utilize more. Okay, this house is called, this effect is called as greenhouse effect. Okay, so here this is our atmosphere. Okay, and if let's say this is fly ash, this is fly ash, and this contains black carbon. Okay, now sunlight is entering into the atmosphere. While leaving, okay, the infrared rays will hit this black carbon and they'll be trapped in the atmosphere only. That's the reason it will be a reason for global warming. Understood? Yes. So generally in your geography you'll get more clarity. Okay, so first disadvantage is aerosol particles. Okay, hyphen write down, which contains black carbon, which contains black carbon, and this black carbon will trap, and this black carbon will trap and this black carbon will trap infrared rays, and this black carbon will trap infrared rays, infrared rays, and leads to global warming, greenhouse effect, and leads to greenhouse effect, and leads to greenhouse effect, and leads to greenhouse effect. And leads to greenhouse effect. Next, see, obviously, second point, whenever they are suspending in the atmosphere, you'll take in, okay, the air you will take in, so obviously it will create respiratory problems. Okay, so second point, affects animals and human health. Affects animals and human health. In bracket write down respiratory problems. Respiratory problems. Write down respiratory problems. Respiratory problems. Understood? Fly ash disadvantages. Okay. So first we have seen this coal ash. Coal ash means residual part. Okay. Whenever we are heating this coal. Okay. And this contains heavy particles, cadmium, arsenic, lead, and mercury. Okay. And then I have told you about fly ash. So this is light in weight and this will be suspending in the atmosphere. Disadvantages: aerosol particles which contains black carbon. Okay, this black carbon, it will trap the infrared rays. Whenever they are trapping the infrared rays, it will create greenhouse effect. Okay, and this, I mean, greenhouse is nothing but this glass house. Okay, this greenhouse name is came after this glass house. They used to construct a house with the help of glass, and this glass will create greenery inside the house. That's the reason this effect is called as greenhouse effect. Understood? This is glass house and this is creating greenery. How? By capturing the sun rays. Yes, that's how it is creating green effect. And this effect is called as greenhouse effect. Okay? Now, second one I have told you, respiratory diseases will be there. Okay? Now, write down advantages. Advantages. Okay? Keep a heading as advantages, write down. See, generally, this coal, I mean, brick industries, cement industries, they are using this fly ash. Why? Actually, the reason is it is fire resistant. It is fire resistant. Whenever you are mixing 20% fly ash in 80% component, then it will become lightweight, stronger, and fire resistant. And fire resistant. So first advantage is fire resistant. So people are using this in cement and brick industries. Cement and brick okay. So obviously whenever they are using this, this is going to be a substituent for Portland cement. Yes, so write down, this is an alternative or substituent for Portland cement. Portland cement means the normal cement which you are using. Okay, so the normal cement is, I mean, in technical terms we will call it as Portland cement. Okay, whenever we'll use 20%, okay, this fly ash to the cement, what it will happen is it will be fire resistant and it will be lightweight and it will be more, I mean, the quality will increase. The quality will increase. So because of this, what's happening is Portland cement demand will decrease. Demand will decrease and Portland cement quality will increase. Quality will increase. So why demand is decreasing here? Before we used to use 100%, now we are using only 80%. 20% demand automatically came down. This 20% is replaced by fly ash and this is increasing the quality. This is increasing the quality. Okay. And I mean, see, you remember this in our childhood, whenever we are building homes, okay, we used to spray water on the bricks. Yes, we used to spray water. Daily we used to do the watering. Okay, because it actually needs watering. Then only the strength will retain. If not the case, it will easily collapse. So here the water is actually required. But whenever you are using a cement wherein you find Portland cement plus fly ash, there generally there also will use water. But the thing here is generally the water consumption will be 20% less. Water consumption will be 20% less. Let's say there, if you're doing watering for 5 days, here you have to do only for 4 days. Okay, so water consumption 20% reduction in water consumption during buildings construction using this fly ash cement. Using this fly ash cement. Understood? Okay. So now if I'll ask you to write a question on fly ash, can you write? Yes, fly ash, light in weight. Okay. And that will be suspended in the atmosphere. Those things will call it as PM 1.0, PM 2.5, PM 10. Okay. And disadvantages are these are aerosol particles which contains black carbon which will trap infrared rays, so it will create greenhouse effect, and then it will respiratory diseases. It will affect humans and animals. Okay. And then we have seen the advantages. Fire resistant. So these are used by cement and brick industries to make the cement and bricks. Okay. And then alternative substance for the Portland cement. By using this, the Portland cement demand will come down and the quality will improve. Okay. And the third point is whenever you are doing watering for the construction of your buildings, if you are using Portland cement plus fly ash, okay, then your water consumption will be 20% reduced. Okay, so these are the advantages. Okay, now the final one we're left with. Adam. Biochar. Okay, first write down, it is a byproduct of biomass gasification process. It is a byproduct of, I've told you there are two byproducts. One is biogas, bio-oil. Okay, so sorry, biochar, bio-oil. So biochar, this is a byproduct of biomass gasification process. This is a byproduct of biomass gasification process. Advantages. Advantages. Richest source of nitrogen and phosphorus. Richest source of nitrogen and phosphorus. Richest source of nitrogen and phosphorus. See, from the childhood, we are learning about fertilizers. Fertilizers will contain nitrogen, urine, phosphorus. Okay. So here, this biochar, it is rich in nitrogen and phosphorus. So obviously, we'll be using this as a fertilizer. Pesticides means the one which will kill the bacteria. Okay. This is fertilizer, which will improve the quality of the soil, which will improve the nutrients in the soil. Okay, how? See, it'll what it will do, I mean, some microbial activities will be there on the soil. Okay, so it will increase the microbial activities. Now, this microbial activities, what they'll do is they'll divide the complex particles into simple particles. Okay, while the division, they'll give nitrogen to the soil again. That's how soil will be rich. So here, if we'll mix this nitrogen, I mean biochar, with the soil, one side the soil will have rich nitrogen content, the soil will have rich phosphorus content. Okay, so it will be helpful for the growth of plants. On the other side, it will increase the microbial activities, and further it will increase the nitrogen content, and further it will be helpful for the growth of plants. Okay, so your second point is it will increase the microbial activities in the soil. Microbial activities in the soil. Here write down this fertilizer. This will be used as a fertilizer. Understood? These 2 points? Yes? This is rich in nitrogen and phosphorus. So obviously whenever you are mixing this with the soil, the first advantage is there will be plant growth. Good plant growth. Second one is it will increase the microbial activities that will further give nitrogen to the soil, and that will further helpful for the growth of plants. Okay. Now listen. There is a process called leaching. What is this process? Leaching. Leaching. Okay. So leaching means, see, let's say this is your land. Okay. And this is your water table. Water table. Okay, you know water table? Okay, you'll dig some deeper, you'll find water. And that water is nothing but water table. Okay. Now, whenever you're pouring water on this land, okay, so slowly it will reach the water table. This process is called as leaching. This process is called as leaching. Now, see, let's say this is plant, and these are roots of the plant. Okay, so these roots will have aerobic or anaerobic respiration. Huh? See, they are underground, right? Aerobic or anaerobic? Aerobic. See, that will take, I mean, that will be aerobic respiration. That's the reason first we'll dig the land. Okay, we'll loosen the soil. Once we loosen the soil, the oxygen will enter into the soil. That's how they'll get the oxygen, and they'll do the process of aerobic respiration. Okay. Now, what we'll be doing is, see, we'll give some chemicals in the form of fertilizers. Yes, we'll give some chemicals in the form of fertilizers, and then we'll do the watering, and then we'll do the watering on this fertilizers. Now, along with the water, this fertilizers will also reach the water table. One, it will pollute the water, which is underground. And second one is the fertilizers which we are given to this plant for the growth purpose. These fertilizers are taken away by the water in the process of leaching. In the process of leaching. Now, what happens is once we mix this biochar with the soil, it will decrease the process of leaching. It will decrease the process of leaching. So the fertilizers which you are given to the plant and the water which you are given to the plant, they will be there in the soil only. They won't go into the water table. So here the biggest advantage is if you are giving fertilizers, once is good to go. But if this biochar is not there and this leaching process is there, then you have to give the fertilizer for 2-3 times. Because once you have given 30%, it was utilized, remaining 70% along with the water through the process of leaching, it went to water table. Second time you will give, it will utilize 30%, and along with the water, it will reach to the water table again. Okay. So third time you will give, then it will fulfill the requirement of the plant. But here in the biochar, once if you are giving, it will decrease the process of leaching. So obviously for once or twice is more than enough. Understood? So it will save your fertilizer as well. And it is protecting your water table from the pollution. Understood? This third point, clear? Biochar, whenever it is mixing with the soil, it will decrease the leaching process. What it will do? It will control the pollution of the water table. Second one is fertilizers. Okay, so the consumption of fertilizers will be less. Okay, so write down third point. Mixing of biochar in soil reduces leaching in the soil. Mixing of biochar in the soil reduces leaching in the soil. Leaching in the soil. Okay, so this is all about biochar. Okay, and this is all about biomass gasification. Understood? Clear everything? Coal ash, fly ash, biochar, pyrolysis. Yes? Now take a short break and then I'll continue with some other topics. Okay? Take a short break. I mean, break is only for 10 minutes and then I'll take the class again. Okay? So, later, after the class, you can have your breakfast. Only 10 minutes break.